Hey guys, and welcome back to another day of physical science at home. Today we're going to be talking about 10.2 again, except day two. Now we're talking about power. Goal for the day is first off, we're going to do a couple of work problems just as kind of a review. Then we're going to jump into what is power, and then we're going to solve some couple equations for power. The thing you're going to want to know today that's different is that power is work divided by time. And we're also going to then sometimes have to substitute in work's equation. Work, remember, is force times distance. So power also equals force times distance divided by time, the whole thing divided by time. So we're going to talk about power, but first let's talk about some work-related questions. Here's the first one. It says, Strongman Sam lifts a 2,000 Newton barbell from the floor to a height of 2 meters. And the question is, how much work does he do in lifting the weight? Take a moment, answer that question. Great, so hopefully by now you got the answer, and the answer is just 2,000 times 2, and that gives us an answer of 4,000 joules of work. That's our answer there. Force times distance is work. That's how you solve that problem. Now, here's another question that's a bit more conceptual. It says, Sam holds the weight over his head without moving it for 1 hour. Question is, how much work does he do while he is holding the barbell? Any guesses? Correct answer here is 0 joules of work. So, since he's not moving the barbell, there's no distance that changes. Since there's no distance, since that d is 0, it doesn't matter how much the barbell weighs, there's no work being done on the barbell. Now, Sam would still expend energy holding the barbell off. He would still get tired, but that also doesn't mean that he's doing mechanical energy. Instead, what's happening here is you kind of jump down a rabbit hole where it comes to biomedical stuff. So as Sam is holding the barbell up in the air, his muscles want to fall down. So the act of like holding them in place and keeping all of his muscles organized in the way that they are, that takes energy, and that's not something we would really talk about. That's not something we would ask you to solve, but just know that no work is being done on the box. The work is being done within his body. So like, for example, his body would start to heat up. That's thermal energy being produced, if that makes sense. So all the energy would be inside his body. No work would be done on the barbell itself. Kind of cool, huh? The next question says, if Sam lets the barbell fall to the floor, what's the total amount of work Sam did on the barbell? Well, so this is saying if he pulls up the barbell, holds it, and then drops it, what's the total amount of work? And that answer is going to be 4,000 joules of work. Letting the barbell fall to the floor, Sam is not doing any work on that barbell, so the answer is just the same as it was before, 4,000 joules of work. Hopefully this helps you see not only how do you solve a work problem, but also what is considered work and what isn't considered work. There has to be a force, and there has to be a distance moved. Those are the two important things there. Cool. Let's talk power. Now, power is known as the rate at which work is done. That's a great start to a definition. We're going to give it a better one. So remember, this power definition has this word work in it. So remember, work is when you push or pull an object a certain distance. So you got to have a force, and you got to have a distance there. So remember, our equation is work is force times distance. Push or pull, that's the force. Distance, that's the d. Power is talking about the rate. So what that means is how quickly you push or pull an object a certain distance. So it has to do with how quickly are you getting work done. So back to the example of the person lifting the barbell a distance, power would be not only are you lifting the barbell a distance, but how fast are you lifting that barbell that distance. So power would change the heavier the barbell is, and it would also change based on how quickly you move the barbell. Kind of cool, huh? So the formula then, like we said earlier, is power equals W divided by T. Or we could say power equals force times distance. Remember, that's W right there. That's work divided by T. So here's just a different way of seeing it. Power is work divided by time. Power is force times distance divided by time. Something that's kind of confusing here is that the units for power are abbreviated capital W. and that stands for watts. Think of like a light bulb, like when we did electricity stuff. Power was always abbreviated in watts. That's the SI unit. That's what they use in like the rest of the world. Oftentimes we'll use horsepower or watts, I guess, if we're talking about electricity. But yeah, we use watts in physics. Get excited for that. Cool. So here I thought I'd give you just kind of like how power applies to Mr. Smith lifting a 50 kilogram box. So if you remember back when we talked about energy, work, and force, we said force was me lifting a box. Work is me lifting a box a certain distance in the air, and that's 980 joules of work if you cared to calculate it. Energy would be after I lift that box 2 meters in the air, the box now has 980 joules of potential energy. So work and energy, very similar here. In fact, they have the same number. It's just kind of saying I was doing work on the box, and now the box has energy. That's the difference there. With power, I would have to incorporate a time. I would have to say it takes Mr. Smith 1.4 seconds to lift the box 2 meters in the air. And because I gave it a certain time, I could use power equals work divided by temperature work divided by time, not temperature, to figure out that I generate 700 watts doing that in that 1.4 seconds of time. So we're going to focus now on how do we get numbers like 700 watts. Sound good? Great. So remember our two equations. These are definitely worth having in your notes. Power is work divided by time, and power equals force times distance divided by time. Here's the question. It says, Mighty Matt is pushing a large table 10 meters across the floor. He exerts a powerful and steady 1,000 Newton force the whole time, and that time is 2 seconds. What was Mighty Matt's power output? If you'd like to try this problem right now, go ahead and pause the video and try it out. If not, follow along with me. So first thing you'll notice here is that I put a red box around 10 meters. That's our distance. So I put a little red box around there. We also have 1,000 newtons. That's a force. So far we've got force and distance. Do we have time? Yes, we do. Can we solve for power? Yes, we can. We're gonna use the second equation here. We do have work, but it's broken up as force times distance. So let's use this equation for power. Let's plug all those numbers in. 1,000 for force, 10 for distance, and 2 for time. When we do that, we're going to get 1,000 times 10 divided by 2, which should be 5,000 watts. There you go. All right, hey guys, that's all I've got for you guys today. Hopefully this was helpful. Hopefully you feel better about power, and have a great rest of your day. Thank you so much.